All right, so this video is to accompany notes 7.1a and also the homework for that. When we want to simplify expressions containing exponents, there are certain rules that we follow. The first one that you can see on the screen is called the product rule. And it states simply that when I have two powers multiplied together where they both have the same base, so in other words, 2 cubed times 2 to the sixth, I just add the exponents. And there's a simple reason why this works. And it's because it's like this. If I have, let's say I have 2 cubed times 2 to the fourth. This is the same thing as 2 times 2 times 2 times 2 times 2 times 2 times 2. So the fourth power is there. The cube is there. And if you count the number of 2's, it is 2 to the seventh, which means we just add together the exponents to get our simplified version of that expression. Next, we have the quotient rule. The quotient rule is similar in that we simply subtract the exponents. So as you see here, as long as we have the same base for both of our powers, then x to the eighth over x cubed simplifies to be x to the 8 minus 3, which is x to the fifth. And again, we can look at why this is the case. Let's just do this one, x to the eighth. I can rewrite x to the eighth as x times x times x times x, and just do this 8 times. Is that 8? Yeah. Divided by x cubed. And then I'm just going to start crossing out the ones that equal 1. So I can cross those out. I can cross those out, cross those out, and I'm left with 5 x's in the numerator, or x to the fifth. Next rule is usually called the power to a power rule. This one says that anytime I have a power, like a to the m power, raised to an exponent, then I end up multiplying the two exponents. So if I have 2 cubed raised to the sixth, then this equals 2 to the 18th, which is 3 times 6. Let's look at why this is the case. So if I have 2 squared and I raise this to the third or cubed power, this is the same thing as 2 times 2, 2 squared, and then we're going to raise that to the third power, which means I have 2 times 2 times 2 times 2 times 2 times 2. And you can see that that's 6 2's multiplied together, or 2 to the sixth, which means I could have just multiplied the two exponents. And finally, for this lesson, the last rule says that any number raised to the 0 power always equals 1. Now, this may seem counterintuitive, but there's a good reason for why this is the case. Let's take an example of, say, 3, well, let's use a better color, 3 to the fourth power divided by 3 to the fourth power. Now, of course, we know that any number divided by itself equals 1. But we can also use the quotient rule that we just talked about by subtracting the two exponents. So I would get 3 to the 4 minus 4, which is 3 to the 0 power. So therefore, these two things are equivalent. So any number raised to the 0 power always equals 1. Here's just some other examples. You can see that all of these numbers, no matter what they are, if you raise them to the 0 power, it equals 1. With one exception, and that is 0 to the 0 power. 0 to the 0 power, as far as algebra is concerned, doesn't make sense. Now, when you get a lot further in your education, you may learn in a calculus course later that 0 to the 0 power can be defined. But for now, for our purposes in algebra, we'll say that it's undefined. Here's why. Let's say I take 0 to the 4th power over 0 to the 4th power. This would give me 0 to the 4 minus 4, which is 0 using the quotient rule. Yet, 0 to the 0 power necessarily means I have a 0 in a denominator. And of course, we cannot divide by 0. Therefore, 0 to the 0 power does not make sense. Let's look at some examples from the assignment. I'm sorry, this is not from the assignment. This is from the notes. So for example 1, we're going to use the rules that we just learned. The first thing we'll do is take the two coefficients and multiply them together. So that gives me 6. Then I'm going to use the product rule for the x term and the x term, and that will give me x to the 4th because I add the exponents. Now I do the same thing for the y terms. Please remember that this y is really y to the 1 power. So when I add the exponents, I get y squared times y to the 1 equals y cubed. And that's my answer. Moving on to example 2. Right off the bat, we should notice that we have a couple of 0 exponents. Remember that any number besides 0 raised to the 0 power equals 1. So I can cross out those two parts of this. And all I'm left with is 4x to the 4th. Example 3, now we have a quotient rule. So the first thing I notice is that, let's use a highlighter here, I can see that 2 over 2 equals 1. So I can ignore the 2 over 2. I don't have to write it. Then I'll do the quotient rule for the x terms. Use a better color. We'll get x squared because 4 minus 2 is 2. Let's clean that up a little bit. Then I do the same thing for the y variables, and I end up with y to the 1 because exponent 5 minus exponent 4 is 1. So I subtract the exponents, and that is my answer. For example 4, this one is a power to a power. So remember the rule said that any number raised to the m power and then all of that raised to the n power, I multiply the two exponents. So just remember that this exponent, since there are parentheses before it, it applies to everything inside the parentheses. That means I'm going to do 3 cubed. So I will put 3 cubed, which is 27. 3 times 3 times 3. Then I need to do x to the 5th power cubed, which is x to the 15th. I multiply the exponents. And then the y is also to the 15th. And there's my answer. So let's take one of the more in-depth ones on the homework, which is number 18. So we have to do several steps on this one, and it does not matter what you do first. I always think it's easiest to handle the coefficients first. So I'm going to look at only, if I can get a highlighter again, I'm going to look only at the coefficients here and multiply the numerators. 2 times 3 is 6. So I end up with 6 in the numerator and 4 in the denominator, and of course that reduces to 3 over 2. Now let's take care of the rest of it. We have an n squared and an n to the 4th in the numerator. First I'm going to multiply those, and I end up with n to the 6th, because remember that when you multiply n squared times n to the 4th, you add the exponents. This n cubed will stay, but I still have one more step to finish this, and that is to simplify the n variables. 3 over 2 is going to stay, but the n to the 6th over n cubed is a quotient rule. So I'm going to leave my n in the numerator and subtract the exponents. 6 minus 3 is 3. So that's my answer. Now another way to think of that, all I'm going to do is I'm going to look at just this part here, and I'm going to rewrite it as n to the 6th over n cubed. I know just by looking at this that it's n cubed over 1. And the way you can tell is because these 3 n's are going to cancel out, so to speak, with 3 of these 6 n's, leaving me with 3 n's in the numerator and none in the denominator. So that's another way you can think of this. Okay, so if you have any questions on this, you can always contact me via email or through the Remind app or on Google Classroom. Thank you.